The limit as n goes to infinity of what? A what? An plus 1 over? You're doing this, right? So I'm going to skip an algebraic step, which I want to do just because I don't like writing it out so many times. It's going to be 2 times n plus 1 over 2n plus 1 factorial times what? 2n factorial over 3 to the 2n. Does everybody see what I did there? Dividing by a fraction is the same thing as multiplying by the reciprocal. That's all I did there. Put parentheses. The easiest way to mess these up, you see where I subbed in n plus 1? Make sure you put parentheses around them. It's really easy to get it wrong, and then it just goes off the rails. So as we continue this, what do we end up with? And I'm not trying to highlight it. Lim as n goes to infinity, 3 to the 2n plus 2 over 2n plus 2 factorial times 2n factorial over 3 to the 2n. Now what cancels? What's the nice one here? Well, that's gone, right? Leaving you just with the limit as n goes to infinity of 3 squared, right? This cancels, and what's left on the bottom here? You end up with what? 2n plus 2 times 2n plus what? Yes. This is the key step. Take a look at it. Goes to what? Yeah. It goes to 0. How do we do? If you want to see more clearly why this is the case, 2n plus 2 factorial is equal to what? 2n plus 2 times 2n plus 1 times what? 2n factorial. That keeps on going, right? So that's why that cancels out. With that? Okay, what's the derivative of just n? 1. So what do you end up with here? So this is the limit as n goes to infinity. I'm not doing L'Hopital's rule again. I'm just rewriting it. Of ln n over what? Over n. 2, not 1. 2 over indefinitely 100%. What does that go to? 0. Okay, so let's look. Why did Mr. Seamon have me do this on this question? If we have now shown that this right here equals what? Do you agree? Yay. Y is bigger than what? 1 over n. This is the harmonic. The harmonic diverges, so therefore the other thing diverges. This is the 100% like complete proof that you could use. This is hard. This is not easy. I am not going to ask you one that is this hard, mainly because I find this to be, this is awesome. I find this to be really illuminating, but knowing to do this is a like random, like it just coalesced in front of you, right? It's hard to do. I mean, this is a cool maneuver. You could file this away for later. Like if you need to prove something is bigger than the other thing, run the limit, right? Put the smaller thing on the top that you think is smaller, put the bigger thing on the bottom. It should go to 0. If it goes to 0, you've shown that this is bigger than that. It's kind of cool. 74, was that the other one? We know that the first present value is going to be m over 1.0075 because r is equal to 0.09 divided by 12, which is 0.0075, just recording everything here. What's our second one? M over what? 0075 squared, and our third one's going to be 75 cubed. How many do we have here? What's the last one going to be? M over 1.0075 to the what power? What's the last one going to be? Yeah, so what's that going to be? 240. Okay, what type of series is this? How do we get what? How many years is the loan good for? 20 years, and it's monthly? 20 times 12, 240. What type of series is this? What is it? Geometric. It's finite geometric. It's a long one, but it's finite geometric. So if we're going to find the sum here, what's the first term? What's our a value? M over 1.0075. And what do we multiply it by? What goes on top? 1 minus what? What's the ratio? What's the ratio between these things? 1.0075 to the what power? That's the ratio, right? That's the ratio between the terms. And what power are we raising this to? to 240th power. And what's all of this over? 1 minus 1.0075 to the negative 1, right? The ratio, everybody. What's the ratio? This is equal to something times m. Find it out using your calculator right now. Go to 3 decimal places, please.